This is worksheet 7.4. So we're working with inverses. So it says find the inverse of each function. Now, this g of x, this function is written in function notation. This is really the same as y equals 1/5 x minus 1. So to get the inverse, you're going to switch the y and the x. So from here, I'm going to rewrite this function x equals 1/5 y minus 1. And so now we want to get y by itself. So we would add 1 and add 1. So on the right we get x, or on the left, excuse me, we get x plus 1 equals 1/5 y. So then to undo multiplying by 1/5, we are going to multiply by 5. So I'm going to take this right side and multiply by 5, and I'll take the left side and multiply by 5. Now what do I multiply over here by 5? The entire left side. So the x and the 1. So 5 times 1 is 5, and 5 times x is 5x. Over here, again, we undid multiplying by 1/5 by multiplying by 5. So our function is now y equals 5x plus 5. This is the inverse function of the function they gave us. There we are. Number 2. Again, this is a y, so it's y equals x plus 4, but now let's switch it up. Let's go x equals y plus 4. Anywhere you see an x, you put a y. Anywhere you see a y, you put an x. And so now let's get y by itself. We'll subtract 4. So we get x minus 4 equals y. So the inverse of the function g of x up above is y equals x minus 4. Here's y. So substitute x in for y and y in for x. You're switching them basically. X equals 3y minus 1. And so we get y by itself. We undo subtraction first. We add 1. So we get x plus 1 equals 3y. Now y is getting multiplied by 3. So to undo multiplying by 3, we divide by 3. What am I multiplying, or what am I dividing by 3 over here? Everything. So we get y equals, because y is by itself, x divided by 3 plus 1/3. 1 divided by 3. There is the inverse function. Number 4. That's the original function. Now let's substitute or switch the x and the y. So this negative 1 is like a multiplier. And so now we're going to have negative 1 or negative y over here. Just like when we had 3 right in front of the x, it became 3y. Getting the inverse, same with the negative sign, so it stays right there with the new y. And now we undo addition first. So we subtract 2. We get x minus 2 equals negative y. So to undo multiplying by negative 1, either divide by negative 1 or multiply by negative 1. Either way. But so now everything over here also gets divided by negative 1. So to simplify, the negatives cancel out here, so we're really just left with y on the right side. On the left side, x divided by negative 1 is negative x, whereas negative 2 divided by negative 1 is going to be a positive 2. So the inverse function is y equals negative x plus 2. There we are. Number 5. Alrighty, so there's our y, but now let's get the inverse. So x equals negative y to the third plus 1. So undo addition first, so we're going to subtract 1. So we get x minus 1 equals negative y to the third. And so now we divide by negative 1, which really just, we take the opposite of everything. So we divide by negative 1, that makes this positive over here, so it's y to the positive third. Of course, what I do to one side, I have to do to the other side, so everything over here gets divided by negative 1. So this becomes a negative x. Uh-oh. My special eraser feature broke down, so all these silly marks. All right, so like I said, x divided by -1 is negative x. Again, we're really just flipping the sign. Whereas the -1 over here is going to become a positive 1. So negative x plus 1. And then y is not by itself yet. How do we undo cubing? We cube root. Oof, it's hard to fit in there. And what we do to one side, we have to do to the other. So cubing undoes, or cube rooting, excuse me, undoes cubing, and vice versa. So over here, our final answer is we've gotten y by itself, the cube root of negative x plus 1. And there's nothing else that we can do to simplify that. So there's our final answer, y equals the cube root of negative x plus 1. Let's try number 6. So that's a y. So now we get x equals -2 plus y minus 2. So oh boy, this thing is funky. We go ahead and write that down. We'll in parentheses y minus 2 quantity cubed. I'll catch up in a minute. Technical difficulties. Still not working. All right, we're going to get through this right now. I tried something, I thought it would fix it, it didn't. So I'm just going to realize it's not going to be good. What I'm using will not be good, but let's go. We're finishing this. So here's y. Now it's being subtracted by 2, but that's in parentheses. And so when I think about undoing that -2 right here, I realize this is going to be one of the last things I undo. The y is also getting cubed. Now I just wrote an x, but I better write a y. It's getting cubed. And then we're also adding. So there's nothing getting multiplied, or it's not getting multiplied or divided by anything. But we are adding a -2 to it. So again, we undo our order of operations from the bottom up. So this -2 I have to undo first. So I'm going to add 2 to each side to undo that. So we get x plus 2 equals, in parentheses, y minus 2 cubed. So I've undone this. Now there's no multiplication or division to undo, so I undo cubing. How do you undo cubing? By cube rooting. So let's do that. So I'm going to cube root. Whoa, get everything in there. I'm cube rooting the entire right side. So the entire right side here now was getting cubed. I had to undo this -2 first because that wasn't getting cubed. And now that I have the entire right side being stuffed, it's all getting cubed, I simply undo it by cube rooting. But what I do to one side, I have to do to the other side. So, and that goes all the way. The entire left side is also getting cube rooted. So now I have y minus 2 on the right side equals the cube root of x plus 2. Now is y by itself? That's our goal, to get this new inverse equation. No, we have to add 2 to it. And what we do on the left, we have to do on the right. So the left side says the cube root of, what's in the cube root symbol? Well, everything that was on the left side on our middle step. So it's the cube root of x plus 2. Now this 2 that we tacked on at the very end is just a regular 2. So it goes outside of it. Make sure it's very clearly not in getting cube rooted. So there is our inverse function, folks. Y equals the cube root of x plus 2 plus 2. There we are. On the bottom, we're going to verify that things are inverses. And so to verify that functions are actually inverses of each other, remember that it doesn't matter what order you write this right now, but g of f of x has to equal x. And, well, this is why I said the order didn't matter, because you have to do it both ways. So then f of g of x has to get you x. In other words, the functions map one another back to the original input. So, and again, if you want to start with f of g of x, that's fine, but this is the way I chose to write it down. It doesn't matter. So f of x is going to be the first input. So this is going to get put in place of x in the function g. So 5 times All right, here we go. 5 times negative 1 plus 1/5 x plus 5. And so we distribute that 5 to everything in the parentheses, everything in that function f of x. So we get negative 5. 5 times 1/5 is 1. So it's 1x, or just x. And then outside of the parentheses, I have this positive 5. So in this part now, I can combine like terms. Negative 5 plus 5 is nothing, or 0. So I'm just left with x. So that part worked, folks. But just because one maps itself into the other back to x, it has to work the other direction as well. So now I'm going to put g of x, that function, in place of x over here. So I get negative 1 plus 1/5 times whatever x is. Now in this case, my input is 5x plus 5. So I get negative 1, and I'm going to distribute, I'm going to take 1/5 of 5x, which is x, and 1/5 of 5, which is 1. So now negative 1 plus 1 is 0, so I'm just left with x. So both composite functions, when we put them together, and mapped themselves back to x. So because g of f of x equals x, and f of g of x maps itself to x, they are truly inverse functions. Let's try it one more time. Let me take f of h of x. Oopsie daisy. You didn't see that. F of h of x. So h is going in place, this whole function is going in place of x right there. So it's going to be 5 times 1/5 x. I don't need the other parentheses. Getting my input function goofed. So again, we're taking 5 times whatever the function h is, and h is 1/5 x. So there we are. And now I just distribute or multiply 5 times 1/5, which is 1, with x. There we go. So this works. This gives me an x. Now let's try the other one, which would be h of f of x. So now this function is my input, and I put it in place of x in the other one. So it's going to be 1/5 times the function f. And the function f is 5x. So now I just multiply that together, and 1/5 of 5x is x. So hey, it mapped itself back. So yes, they are truly inverse functions. Sorry, the tablet was not working so well. I'll get that fixed.